Hello everyone, we're Team 9. Today we're presenting our data visualization project about Seoul's lost and found records. The title of our project is What Doesn't Belong Here? In this project, we looked at Seoul through the objects people accidentally leave behind. When we first chose our topic, we wanted to use a data set that was both interesting and easy to relate to. Many public data sets contain valuable information, but sometimes they feel a little distant from our everyday lives. We wanted something that people could immediately connect to. That led us to a simple question. What do people lose in Seoul every day? Most of us have lost something before. Maybe a wallet, a phone, an umbrella, or a pair of AirPods. And we usually remember how annoying or stressful that moment was. That is why lost and found data felt interesting to us. Each record is not just a number in a dataset. It represents a small moment from someone's daily life. It can show where people move, what they carry, and what they consider important. So instead of looking at Seoul through data like traffic or population, we decided to explore the city through the things people leave behind. Our data comes from Lost 112, which is the public lost and found portal operated by the Korean National Police Agency. We collected the data by using the Public Data Portal API. The portal contains two different types of records. The first dataset consists of found items, objects that were discovered and reported by someone. The second dataset contains lost items reported submitted by people who lost their belongings. Together, these records show many small incidents that happen across the city every day. In total, the nationwide dataset contained approximately 210,000 records. But for this project, we focused only on Seoul. After filtering the data, we analyzed roughly 67,000 records collected between January and May of 2026. This gave us enough data to identify both common patterns and unusual cases. The dataset includes several important fields. For example, it has the item name, item category, color, date of loss, location of loss, institution name, institution phone number, and item status. These fields helped us understand what kinds of items were reported, where they were lost or found, and which institution handled them. But there are also some limitations. The first limitation is recovery. Although the dataset tells us that an item was lost or found, it does not tell us whether the item was actually returned to the owner. Also, lost item reports that and found item records are stored separately. Because there is no direct connection between the two, we cannot accurately calculate recovery rates. The second limitation is that this data does not show every item people lose. It only shows the items that people decided to report. For example, if someone loses a phone or a wallet, they will probably report it quickly. But if someone loses a cheap umbrella, they may not report it at all. Also, some items may be handled directly by subway stations, bus companies, airports, stores, or other places without being recorded in Lost 112. So this dataset is not a complete list of everything lost in Seoul. Instead, it shows what people considered important enough to report. In other words, the data tells us not only about lost objects, but also about people's priorities and behavior. Before starting the visualization, we had to clean and organize the data. First, we filtered the dataset to include only Seoul records. At first, we considered filtering by agency name, but agency names were not always written in the same way. Some included the word Seoul, but others only used district names. So, using agency names could make us miss some Seoul records. To avoid this problem, we used institution phone numbers instead. Since Seoul's area code is 02, we kept the records where the institution phone number starts with 02. Second, we restricted the analysis period to January through May of 2026. This helped us keep the analysis period consistent and manageable. Third, we processed the category information. The original dataset stored item categories as hierarchical labels. To make the data easier to analyze, we separated these labels into major and subcategory fields. Finally, we created new variables from the data information, such as month and day of the week. These variables allowed us to explore temporal patterns within the dataset. After completing these pre-processing steps, we were ready to begin exploring the data itself. And from that point, we started by looking for patterns in the data.
Before we move on to our more unique visualization approach, I'd like to briefly introduce some of the general findings we observed through conventional data visualizations. This chart compares the category distributions of found items and lost item reports. Lost item reports are heavily dominated by wallets, which account for more than 40% of all reports. In contrast, found items are distributed much more evenly across categories. Electronics, cars, cash, and various items all appear in substantial numbers. This suggests that the items people report losing and the items that are eventually found do not follow exactly the same pattern. One possible explanation is that wallets have a high personal value. They often contain cash, cars, and identification, making people much more motivated to report and recover them. Overall, lost item reports are concentrated on wallets, while found items are spread across a much wider range of categories. Next, we looked at where found items were recovered. The largest share of found items comes from train stations, accounting for roughly 1/4 of all records. Street and sidewalks follow closely behind, while subway stations and centralized collection facilities also make up a significant portion. Together, these locations account for the majority of all found items. What these places have in common is movement. They are locations where large numbers of people pass through every day while commuting, traveling, or simply going about their routines. This suggests that lost items are not randomly distributed across the city. Instead, they tend to cluster in high-traffic environments where people are constantly on the move. While the previous chart showed where items are generally found, this heatmap reveals a more detailed pattern. It compares item categories with recovery locations and shows that different types of belongings tend to appear in different environments. For example, mobile phones are most commonly found on street and in taxis, suggesting that they are often dropped while people are moving between places. Clothing and bags show a very different pattern. A large proportion of both categories is recovered on trains, making public transportation a key recovery environment for these items. This chart shows the total number of found items by day of the week. Weekdays consistently record more found items than weekends. Friday has the highest number of cases, while Sunday has the lowest. From Monday to Friday, the numbers remain relatively stable, but they decline noticeably over the weekend. This suggests that lost and found activity is closely tied to weekday mobility, especially commuting and routine travel. In short, the weekly pattern of found items appears to reflect the weekly rhythm of city life. While the previous chart focused on overall volume, this heatmap highlights differences across item categories. Bags and clothing are recovered more often on weekends, especially on Saturday and Sunday. In contrast, wallets and cards become noticeably less common during the weekend. Meanwhile, mobile phones remain relatively stable throughout the week, showing little variation by day. It means different types of belongings follow different weekly patterns. This chart compares the share of lost item reports and found item records for each category. If a category appears more often in lost item reports, it falls on the left side. If it appears more often in found item records, it appears on the right. The most noticeable example is wallets. Wallets show by far the largest reporting gap, appearing much more frequently in lost item reports than in found item records. Phones and identification documents show a similar pattern. In contrast, cash and cards appear much more frequently in found item records. One possible explanation is that people may have less incentive to report them. Cash is often difficult to recover once it is lost, and bank cards can usually be cancelled and reissued. This suggests that the dataset reflects not only what people lose, but also what they choose to report.
Up until now, our analysis has been fairly conventional. We looked at the basics, common items, recovery spots, and reporting patterns. The results were exactly what we expected. Most items were predictable, and the data followed clear, established trends. But as we dug deeper, some old records kept catching our eye. Things like a set of dentures in a subway station, a watermelon on a city street, or a bag of onions left in a taxi. Statistically, these were just one of outliers with no real significance. Yet, they stood out far more than the thousands of ordinary cases we'd seen. This led us to a simple question. Instead of focusing only on what happens most often, what can we learn from the things that happen only once? Data analysis is usually all about finding patterns. Patterns show us what's common and representative, which is often exactly what we need. But there is a trade-off. We tend to ignore the rare events. We call these outliers, and in statistics, they are often dismissed as noise. That approach usually makes sense, but in our dataset, these outliers were surprisingly interesting. Patterns tell us what happens most of the time, but outliers show us the unexpected. That simple observation became the starting point for our next step. Rather than asking what happens most often, we began asking what happened only once. As we examined these unusual records more closely, we noticed that they encouraged a different kind of interpretation. Most records simply describe an object, a location, and a date, but some records naturally raised questions. For example, when we saw a watermelon reported on a city street, we immediately wondered how it ended up there. The dataset does not provide an answer, but that uncertainty makes the record interesting. Unlike common patterns, these unusual records invite people to imagine possible situations behind them. For us, they felt less like typical statistics and more like traces of everyday events. Because of that, we decided to use outliers as the foundation for our visualization. Once we decided to focus on outliers, the next question was how to identify them in a structured way. We wanted a process that was more objective than simply choosing items that looked unusual, so we established two criteria. The first was rarity. We looked for objects that appeared very infrequently within a particular location category. For example, finding a wallet in a subway station is common, while finding a watermelon there would be extremely rare. The second criterion was contextual mismatch. This refers to objects that seem unexpected in a particular environment. A shopping bag inside a taxi feels understandable, but a large household appliance would feel much less expected. Using this criteria, we first extracted low-frequency candidates from the dataset. We then manually reviewed the records and selected cases that were both rare and contextually unusual. Importantly, every outlier shown in this project comes directly from the original dataset. None of them were added or modified by our team.
Now I will introduce our final visualization. In the previous part, we analyzed what kinds of items are commonly lost in Seoul, where they are usually found, how the patterns change by category, location, and the day of the week, and the reason of why we selected outliers. For our final visualization, we wanted to focus less on the most common patterns and more on the unusual items hidden inside the data. So instead of showing these outliers on these two charts, we turned them into an interactive hidden object game. Once we had the game structure, we needed a narrative framework. We wanted a character that could naturally question things that local residents take for granted. That's how Jet9 was created. Jet9 is an alien observer stranded in Seoul. After crash landing on Earth, Jet9 loses the pieces of a coordinate device needed to return home. Those pieces have mixed into Seoul's lost and found system. So the player travels across the city searching for them. We chose an alien for a very specific reason. An alien is also an outlier, just like an outlier. Jet9 doesn't understand what is normal and what is unusual. It has no cultural context. Because of that, it can ask questions that humans normally wouldn't ask. For example, when people see a bag of onions in a taxi, they might laugh and move on. But Jet9 treats it as an important scientific observation. This perspective allowed us to transform lost item records into small moments of exploration and imagination. The game takes place across a series of locations inspired by places that frequently appeared in the dataset. Players move through streets, bus stops, buses, subway stations, makers, exits, and finally DDP Plaza. Each scene contains two kinds of items. The first type is ordinary objects. These things like wallets, umbrellas, objects that appear frequently in the dataset. When players click on these items, they receive statistical insights based on our analysis. The second type is outlier objects. These are the unusual records selected during our review process. When players discover these objects, they unlock a field note written by Jet9. Importantly, these notes do not explain the object. Instead, they speculate about it. They imagine what an outsider might think when encountering something so strange. This design allows the data to remain factual while still encouraging interpretation. As players progress, they collect all of the missing coordinate fragments hidden throughout the city. When, after completing the final scene, they reach one of three possible endings. Jet9 may successfully return home. Jet9 may decide to remain on Earth. Or featuring Jet9 may lose the coordinate device all over again. The final ending became our favorite because it reflects the nature of the dataset itself. Patterns can be predicted. Individual stories cannot. Now we'd like to briefly demonstrate the game. Here we can see one of the scenes. At first glance, it looks like a normal urban environment. But hidden among objects are several outliers waiting to be discovered. For example, let's click on this. When an outlier is selected, the player sees the original lost item record along with Jet9's observation. The goal is not to explain exactly what happened. The goal is to encourage curiosity. As players continue through the scenes, they begin to notice the contrast between ordinary lost objects and unexpected ones. And through that process, they experience the same shift in perspective that we experienced while analyzing the data. The game becomes less about finding objects and more about paying attention to the expressions. Looking back, this project began with a very ordinary analytical question. What patterns can we found in lost and found data? And we found many. We found common objects. one location, predictable distribution. But over time, our attention shifted toward the exceptions. The records that appeared once became more interesting than the records that appeared thousands of times. Not because they were statistically important, but because they revealed something that averages could not. Through these outliers, we became more aware of the limitations of data collection, the diversity of urban spaces, and the unpredictability of human behavior. Most importantly, we were reminded that every record in a dataset originates from a real moment in someone's life. A chart can summarize thousands of records, but sometimes a single unusual record can make us think much longer. This project taught us that data analysis is not only about finding patterns, it is also about interpreting exceptions. Thanks for listening.